Today's webinar will cover UST Systems at Marinas, and it's offered as part of NUEPIC's ongoing UST Inspector Training webinar series. Speakers will discuss the design and testing of UST systems at marinas, applicable standards, recommended practices, fire codes, and the federal UST regulation will be discussed. And now I'd like to introduce today's speakers. Tim Smith is a member of US EPA's Office of Underground Storage Tanks, also known as OUST, the Release Prevention Division. He's OUST's point of contact on several federal UST regulatory requirements and program issues, including release detection, UST compliance inspector training, operator training, and inspections. Tim has been with OUST since November of 1998. David Stone is a graduate of the University of Tennessee, Knoxville with a degree in environmental studies. He worked with Jacobs Engineering Group prior to taking a position with the Tennessee Department of Environment and Conservation in the Water Resources Division. He transferred to the UST Division in 2006 as a compliance inspector and now serves as the chair of the division's Marina Committee. Steve Latimer is a 26-year veteran of the petroleum equipment industry. Working in distribution as a technical sales associate for 23 years, Steve specialized in mission critical, commercial, and marina fueling system applications. In 2018, Steve made the transition to manufacturer's representative, where he continues to work with engineers, contractors, distributors, and end users of such systems to ensure projects are specified and installed correctly, utilizing the right equipment for the application. With that, it's my pleasure to kick it off to today's first speaker. Happy to welcome Tim Smith with EPA's Office of Underground Storage Tanks.
Thank you, Drew. My slides should be showing on screen now.
Yep.
Great. That's always a plus to start off well. As Drew mentioned, my name is Tim Smith. I'm with EPA's Office of Underground Storage Tanks. I won't bore you with the details of how long I've been there. I think Drew, he did mention, wow, it's hard to believe, 23 years. I am the point of contact for release detection related issues, among other things. This morning, I would like to talk about really briefly federal UST requirements for release detection that are applicable to marinas. I'll touch on tank release detection requirements, but my main focus is going to be on, for this webinar, piping release detection. I'll talk about some features of these systems, probably more accurately, a component of these UST systems that present a challenge to meeting the federal UST release detection requirements. I will end with a brief discussion about release detection for the entire system and release response requirements. The original UST regulation became effective December 22nd, 1988. The release detection requirements were actually phased in for over a 5-year period until 1993. All of the tank and piping release detection requirements applied to these marinas. They still apply. The general requirements are owners and operators must use a method or a combination of methods that can detect a release from any portion of the tank and the connected underground piping that routinely contains product. I want to stress the underground piping. The regulation is focused on the underground piping for these systems, connected underground piping, and the tank. That will play in some of the points that I make and other speakers will make during this webinar. The UST system or the release detection equipment or methods, they have to be installed and calibrated in accordance with the manufacturer's instructions. I want to talk real quickly about tank and piping specific requirements. Very briefly, the monitoring for releases at least once every 30 days is required for the tank. Some tank methods you guys are probably already familiar with: interstitial monitoring, the automatic tank gauge, SIR, statistical inventory reconciliation, and it's pretty much companion, the continuous in-tank leak detection system, which is a hybrid ATG and SIR combination. Manual tank gauging, groundwater or vapor monitoring is still allowed under the federal UST regulations. There are few new requirements for it that owners and operators using these systems or methods, they have to keep the report of the installation for the life and use of the system, something different from the original regulation. And of course, there's always that other method. The federal UST regulations recognizes other methods under two categories. Either it meets the 0.2 gallon per hour leak rate, or something recognized by the implementing agency as acceptable for the system. For the piping requirements, the suction piping, it is exempt from release detection requirements, but it's only exempt if there are four design characteristics that have been met. The four characteristics are: the below-grade piping has to operate at less than atmospheric pressure. The below-grade piping has to be sloped back to the tank so that if suction is lost, product must flow back to the tank. There can only be one check valve installed in each suction line, and the check valve is below and as close as practical to the suction pump. Now, all of that has to be, owners and operators have to provide a method that allows ready verification that these design characteristics have been met. Without that, the other design characteristics or that exclusion or allowance, if you will, it's not allowed if it can't be proven. Otherwise, for suction systems that aren't safe, there is a once every 3 year line tightness test that's required, or owners and operators can choose a tank method that's applicable to the lines. For pressurized piping, each one of these systems requires the use of an automatic line leak detector. The automatic line leak detector has three options. All of the options have to meet a 3 gallon per hour, be capable of meeting a 3 gallon per hour release at 10 pounds per square inch pressure, or the equivalent within 1 hour. The options include slow flow of product, which is typically done by a mechanical line leak detector. Owners and operators for these systems, the method or combination of method can trigger an audible or visual alarm, or the popular one is shutting down the submersible turbine pump. You don't have product flowing, and that is definitely an option for the federal requirements. In addition to the use of a line leak detector, owners and operators for these pressurized piping systems, they are required to meet two forms of release detection. Owners and operators can perform an annual line tightness test, or they can provide a 30-day tank method that's applicable to the piping. These requirements are specific to certain types of tanks that I'll talk about later based on the installation date. There are definitely variations or recommendations by codes of practice that might be slightly different than the federal requirements, if you will. One of these is RP 1000. Wanted to unpack this really briefly, where there's a lot here on the slide, but really makes sense, where the federal UST regulations, we rely upon codes of practice and industry standards. As long as the standard is consistent with the regulatory requirements, it can be used. These standards provide tried and proven technical solutions to help us owners and operators achieve compliance. That's the definite name of the game. These standards are more easily updated than the federal UST regulations to reflect current technological advances as well as environmental concerns, where the federal regulations may say 3 options, but the code might call for a specific option to be used. Not that other options can't be used, but the code has really deemed it really appropriate to use a certain option here. And one of those I've highlighted here, where if an electronic line leak detector is used according to the code, it should provide positive shutdown if that 3 gallon per hour scenario is encountered. That we will talk about very briefly in a couple of minutes, but it has to do with containing leaks and ensuring that the leak of product from that piping doesn't go any further. It's really doesn't become a major problem here. Also, the codes of practice, they go way beyond the federal requirements, where the federal regulatory requirements are basic, so to speak, but the technical issues are addressed by the codes. One of the technical issues that PEIRP 1000 addresses is the use of an anti-siphon valve. If it's used, the code calls for installation of the leak detector downstream of the anti-siphon valve. Again, the codes, they really handle the technical concerns. They really get to the nitty-gritty beyond just the basic federal requirements. Owners and operators have to verify that the line leak detector is certified to function with the type of fuel. This is definitely a major concern. If you use, owners and operators use a MOGAS or gas line leak detector for a diesel system, those numbers are not valid for the use of that particular type of fuel. Something that the federal requirements does not require, but a lot of states do require, it's that the equipment or method be listed by a third party or be listed by some organization. That organization that is the National Work Group on Leak Detection Evaluations. And even though the federal requirements don't specifically require use or listing with National Work Group on Leak Detection Evaluations, that particular organization has become the go-to for listing of and identifying criteria like the length and diameter of the underground piping that can be used at certain applications. Even EPA, we use that. We can't require it, but it becomes the first source of, is this method valid or not? Now with that, looking at the listings on the National Work Group evaluation page, they identify not necessarily restrictions, if you will, of the method can't go beyond, but the federal requirements, it requires that the use of a method or a combination of this method, it has to meet certain performance standards. So what owners and operators or what manufacturers of these equipment and these methods have done, they've evaluated those systems based on a certain laboratory setup, or in some cases in-field setup. But the restrictions, if you will, they come into play from the parameters or extent of the actual equipment on site or at the laboratory. Now the listings, they don't necessarily say that if you add another 100 feet or 10 feet, it won't work. It's just saying that that particular method or combination of methods or equipment can, and it has been proven to meet the EPA performance standards to the criteria or parameters listed on that particular listing. Another issue here in unpacking the code here, the codes go over a lot of background and some technical concerns that the regulations don't have the time, or it's not really set up to do to provide. One of the issues with the marina fueling is of course, piping, where the above grade piping, the federal requirements, we require only the testing and verification that the underground piping has met performance standards. But from a full system approach, there is a whole lot of issues with the above ground piping that's not really covered by the US regulations, but Owners and operators still need to pay attention to, and they still need to basically make an effort and include in their release detection requirements and their concerns for impacts to the environment that above ground piping. We'll get into that a little further in a minute or so. There are some changes based on the new federal UST requirements that from 2015, as of April 11, 2016, tanks and piping that are installed after this date, release detection methods options for those installed before, owners and operators can use those methods I listed, interstitial monitoring. They can use the line tightness test for piping. However, after the April 11, 2016 date, according to the federal, now you have to look at each individual state's requirements because these dates may change, and they will in most cases. But if it's installed according to the federal requirements after April 11, 2016, owners and operators, they have to install their systems, tank and piping, to meet the secondary containment requirement. They have to be either double walled or secondarily contained in some form or fashion. They must also use interstitial monitoring as their primary release detection method. They can combine those, but primarily speaking, the interstitial monitoring has to be done. Owners and operators for those systems after April 11, 2016, they have to install under dispenser containment. There are walkthrough inspections that are associated with the piping at marinas. Owners and operators have to meet the 30-day release detection equipment checks. They have an annual containment sump check as well. And of course, if they're using the piping for interstitial monitoring, then they have a 3-year test of that containment sump for that interstitial monitoring purposes.
Tim, this is Drew. Sorry to interrupt.
Yes.
We're coming up on the 120 mark. So if you can.
Great. I'll wind down real quick.
Thanks
a lot. Yes, the release detection requirements for the equipment testing, those are the same as for conventional systems. There's a 3-year record requirement for those. It targets the line leak detectors, sensors, anything associated with that release detection for those systems. There are definitely concerns with the piping. These pipings are long, they change grade. There's lack of insulation or isolation, unfortunately, from the transition from the underground to above ground to more easily provide that release detection for the underground. The scope of the regulations is for that underground, but from an entire system approach, of course, owners and operators want to do full environmental protection when addressing release detection for the entire facility. They don't necessarily have to do that for the release detection or to meet the US requirements, but from a full system approach, it just makes sense. But not only does it make sense, the impacts to above ground areas from releases are addressed or covered in the federal US regulation. If there's an impact from above ground releases to subsurface or the surface water, then that is definitely a concern addressed by the 40 CFR 280. There's also concerns with impacts to navigable waters. SPCC takes over at that time. And I provided some information on the SPCC requirements. I won't talk through these. I provided this for your reading pleasure after the webinar, but it provides the contact information for SPCC requirements. Not only possibly is the impact from surface water addressed under 40 CFR 280, but SPCC gets involved. I will end there and ask if there are any questions. I think I have time for maybe one, maybe two.
Yeah.
Let me slide through with two.
Great, absolutely. Yeah, thanks so much, Tim. We did get a few questions. I think some of these are highlighting some topics that we might get into later in today's presentation, but let me pick one to read off to you. And I appreciate Steve took an attempt at actually answering a couple, but so one of the ones I wanted to ask Someone's seeking a clarification on what you had said. So the question is, clarify, if a facility is using the 0.3 gallons per hour electronic monthly monitor,
Yes.
you would require all marinas to have positive shutdown. They say, I thought this was only for facilities built after '09.
No, that requirement for positive shutdown comes from the code. EPA's allowances for automatic line leak detection is 3 options: shutdown, vacant slow flow, or audible or visual alarm. Again, the positive shutdown is specifically for the from the code. So all 3 options are available under the federal requirements.
Great. One earlier one here, does safe suction require release detection?
Not safe suction, no. If it meets those 4 design criteria that I've mentioned, slope, that sort of thing, release detection requirement is not applicable. All the other requirements, clean up, if there's a release, all of those are applicable, but not the release detection requirement.
Great. I'm going to give you 3. So
Okay,
the third
good.
one here. Clarification, does underwater piping fall under the same regulations as underground piping?
The short answer is possibly yes, because of the above ground release that includes releases to surface water. If that piping is a part of the US system, then yes, that the 40 CFR requirements do apply, where that would be a release to surface water. Not only would 40 CFR 280 apply, but of course, the facility most likely falls under SBCC requirements. So SBCC requirements would apply as well.
Great, thanks. We're going to do one more. A question just came in about interstitial monitoring, and a question
Sure.
came in previously on that as well.
Mm-hmm.
The previous question, it does hint at a topic that NUEPIC will be doing a webinar on emergency power generators later in the year. But the question is, can all UST systems now or in the future use the EPA draft proposed AIM method for IM for emergency generators to achieve the ALLD requirement inherently with IM?
Very good. For those that aren't familiar with the automated interstitial monitoring system, AIM, that is a design of the work group that we're working on that with EPA. That AIM system allowance, if you will, is only for emergency power generator systems. There are restrictions based on certain NFPA codes, NFPA 30A, that it doesn't lend itself for use at conventional facilities. But as Drew mentioned, there is a webinar, I believe it's on the 14th, correct me if I'm wrong, of December, Drew. We will talk about a little bit more about the AIM systems and the use of that at emergency power generator systems in general.
Yep, that's correct. December 14th,
right.
and we'll get you all registration information soon. You can find that info on the same spot you found it for this. So. All right. Well, thank you so much, Tim, for what you presented there and for fielding some of those questions. Folks, if I didn't get to all your questions, we'll see if we have any time left toward the end. And worst case, I can work to share your questions with Tim after the fact and try to get you an answer post-mortem here for the event. So thanks so much, Tim. Appreciate it. All right, well, next I'm happy to introduce our next speaker. David Stone is with the Tennessee DEC. Take it away when you're ready, David.
Let's see. Well, bear with me just 1 minute. I'm trying to get to the, here we go. Well, unfortunately,
So your control panel might be hiding things from you, but
it is.
Yeah, if you click that slideshow on the ribbon there.
Slideshow. Well, it wasn't, unfortunately, it wasn't covering it when we went through it earlier, but it is now.
David, if you double click the top ribbon to make that into a smaller window, you should be able to see that slideshow button then.
Okay, let me see if I can. That's not doing it.
The little box right next to the close window button in the upper right, hit that little one, the one to the left of the X. Not that one, the next one over, that one. Should make that a smaller window. You should be able to see your slideshow.
Ah, yes. Okay, there's more than one way to skin a cat. All right.
All right, take it away, David. Thanks, Steve.
All
Appreciate
right.
it.
Sorry for the delay, everybody, but good afternoon. And I appreciate everybody taking time to attend the Marina UST Systems webinar today. When Drew asked me to give this presentation with an emphasis on Marina UST Systems in Tennessee, I felt that it would be best to focus on TDEC's UST Marina Committee and what we have done to more effectively regulate these types of UST systems. This is an example of one of the UST marina systems we have in Tennessee. I'll give you a little background. When I first started with the UST division as a compliance inspector, most of my inspections were at traditional retail fueling facilities, C-stores and truck stops. But occasionally we did run across a marina, and I found that they were extremely different. The pipe lengths were much longer. As Tim had mentioned, the differences in elevation from the tanks to the dispensers was much greater. And the pipe materials and equipment that we found was often very unfamiliar. This is a photo of Hurricane Marina. That's located in Middle Tennessee. The Marina Committee, prior to us going out there, we wanted to measure the linear feet of piping since it was one of the larger marinas that we had. There's actually much more piping than what is shown in this measurement, which is 2149. Since there is some piping that is coiled on the bottom of the lake to accommodate vertical movement during flood. And then there's also some extra pipe at the transitions to allow for horizontal movement during high wind events. There's also significant elevation loss from the tanks to the dispensers, which is different than what you find in a traditional retail fueling facility. There was some mention earlier in the comments about safe suction piping. I have never seen safe suction piping in a marina because the tanks, as you can see here, are generally located up out of the flood zone. And the dispensers will be found on the docks down on the water. So there is no way for product to flow back to the tank in this type of situation. The flood zone here that you can see generally comes up past to where the cars are. When I went out to this marina facility in the photo on the left for the first time, the pipe was registered in our database as flexible plastic pipe. However, I couldn't find anything like it on our Flex Pipe ID guide. After some research, I later discovered that it was fuel transfer hose that had been run all the way from the tank to the dispensers. Checked with the manufacturer of the hose and was told that it is not designed for permanent installation and should not be in prolonged contact with the ground or water, since the material, much like rubber tires, which is the same material this hose is made of, it is permeable and may leach product to the environment. The photo on the right was of a different marina, and it shows a solenoid valve adjacent to the STP. Had a little bit of a question about this. I later discovered that the anti-siphon device was positioned properly, as it should be at the tank, but the leak detector being upstream of the solenoid would not work on the piping, so it had to be moved downstream of the solenoid to function properly. So we did have some questions about these things. They weren't very similar to the traditional type of facilities that we dealt with. And just to be honest, they really weren't similar to each other. Most of them were one-offs. So we decided to look into it a little closer and started doing some research. The first thing we found when searching the internet was the Marina Fueling Facility Project Report that came out of California Water Resources Control Board. It was published in 2006. The California Marina Fueling Facility Report found that most marine fueling systems are not designed, constructed, or operated to prevent fuel releases. 75% of the fuel pipe that they found was single-walled. About 50% of the fuel pipe was over water, underwater, or floating on water, and approximately 80% of the fuel pipe was not monitored for fuel releases. They also found that releases from the poorly designed systems, that's their word, can be detected only after hazardous substances have entered the environment. And they also found, as we found as well, existing laws and regulations are inconsistent across regulatory programs, and in many cases, no requirements exist at all. So the report did have a few suggestions. They suggested upgrading their marina fueling systems. That would include installing fully double-walled systems, using continuous electronic leak detection between the primary and secondary containment, having all pipe used in above-ground applications to be approved by an independent testing organization in accordance with industry standards. They also suggested using anti-siphon devices, and they also suggested having emergency shutoff switches installed. They did note that to effectively regulate the marina fueling systems, both the ASTs and the USTs should operate under the same requirements. If you're in a state that they both operate under the same program, you're better than most. If you're in a state like Tennessee that only does the USTs, oftentimes you will have people flee to the other side with the ASTs that are often less regulated. While doing research, I had a coworker, Lamar Bradley. If you've been around for a while, you might recall Lamar. He sent me a copy of the Petroleum Equipment Institute RP 1000. That was their first issue in 2009. And it was quite a revealing document. Since, I was a retail compliance inspector for the most part, I was familiar with RP 100 because it had a lot of those designs for those types of systems, but I wasn't aware of RP 1000 or a lot of other PEI's documents. So this document taught me a lot about marina fueling systems, how they should be designed. And it even had some references to NFPA fire code in the document that I wasn't aware of. So that led us to the next thing that we looked at. We pulled out a copy of the NFPA 30A and found that they do have a marina fueling chapter. That's chapter 11 in the fire code. NFPA 30 had quite a few things in it that 30A, I'm sorry, had quite a few things in it that we didn't really see out in the field. There was a requirement for down gradient piping to have an anti-siphon device. That is, if the pipe does rupture, it won't drain the tank contents as well. It also required shutoff valves to be provided at the shoreline and at the shore end of the dock pipe. Oftentimes there was just pipe running out to the dock without any sort of shutoff or breakaway even. It also required marina pipe to be protected against physical damage and stresses from impact, settlement, vibration, expansions, contraction, and tidal action. Unlike your traditional retail fueling facilities, these docks do move around, and they move around a lot. Both due to water movement, water coming in and out of the reservoir, and also high wind events during storms. We also found in the fire code that hose lengths exceeding 18 feet needed to be secured as to protect it from damage as well. Also, dispensing nozzles needed to have the automatic shut-offs removed, the latch opens devices. And then one requirement that I found interesting was each marine motor fuel dispensing facility should have an attendant or supervisor on duty when the facility was open for business, and that person's primary function was to supervise, observe, and control the dispensing of liquids. So essentially, most marina fueling facilities should be full service. Next, we started to look at some of the reservoir managers' requirements because these facilities, although they are privately owned, they're often on public land. So we first started looking at the Tennessee Valley Authority requirements, since many of our marinas in the East Tennessee area and some in the Middle Tennessee area are located on the reservoirs. We found Section 26A of the TVA Act. That's for fuel storing tanks and handling facilities. It did require after 2003 for systems below the 500-year flood elevation on a reservoir to have a few things done. They had to have a copy of the state approval submitted. TVA does require secondary containment for all piping associated with the UST. They also require secondary containment for gas dispensers. They require calculations by a professional engineer showing how the tank will be anchored so it does not float during flooding. And then they also, as Tim mentioned, wanted evidence of the SPCC requirements being met. We also have some Corps of Engineer reservoirs in Tennessee. So we looked up their environmental assessment management team guide. Each state does have its own supplement. So in the Tennessee supplement, we looked at it, and essentially it is a reprint of our regulations. So I assume that each state that they have this supplement in contains their regulations as well. But it's for their inspectors when they go out to look at the marinas. They are supposed to check the fueling systems. However, talking with the Corps people, they leave it mostly up to us since they're aware that we're there as well. So next we looked at our, we want to take a closer look at our UST regulations and see what they, what they had in it for marina systems. Since we didn't have a marina section, we had to look at some of the general rules. The first rule here stated that all underground storage tank systems shall be installed in accordance with the manufacturer's installation instructions. So that played into what we looked at. There was also the requirement in the next rule that UST Systems shall provide a method or combination of method of release detection that is installed and calibrated in accordance with the manufacturer's instructions. And our third rule that we referenced as applicable to marina systems is the rule that we have that it has to have a third-party evaluation and be listed with the work group. So whatever the work group has or their third-party evaluation has as far as length, volumes, materials, that has to apply to what they have out in the field. So we started getting into what are the manufacturer's instructions. So as I mentioned earlier, with the leak detector being on the wrong side of the solenoid, we started looking at some of the leak detector manufacturers. This is a Red Jacket field service bulletin. You can see from the date there, if you have good eyesight, that it's way back from April of '88, but it is still applicable today for their installations. We also looked at Vaporless. Gabe, I saw that Gabe was on this call. He provided me with this technical bulletin that applied to above ground storage tanks and marinas. Above ground storage tanks and marinas, they're similar because they both have down gradient piping. So that's what they apply here. You can see that they do have the normally closed solenoid, and then they also allow for, I guess, pressure reduction in the line due to some thermal influence that you're going to get from the above ground pipe. And then we also looked at Effie Petro. We talked to Josh Norgard. I don't think he's there any longer. But when we spoke with him, he said they did not have any specific marina installation instructions, but they did have some warnings and cautions that would apply in their installation instructions, that it does have to meet fire code, does have to meet industry standards and practices, which he referenced the RP 1000 as being the industry standard in the instance of marinas. And you'll also see a note there at the bottom that the leak detector units are designed to detect leaks where it's installed and downstream. So any pipe that you might have upstream of it needs to have some sort of second means of monitoring. So when you do offset these leak detectors, there is going to be pipe upstream going from the leak detector to the solenoid and from the solenoid to the STP. It is not going to be protected by that leak detector. So you do have to have something there in case there is a leak that the leak detector can't catch. We also started looking at pipe manufacturers because we had a lot of rubber hose, fuel transfer hose. One facility we had even had general purpose hose meant for air and water that they were running petroleum through. And we also came across some, I guess UL 971 rated underground piping that they had put out baking in the sun on the shoreline and also on the dock. So we started to look to see if there was any marina piping that was actually meant for marinas. The first one that we found was APT. They do have an XPMD product. MD stands for metal ducted. It's essentially a combination of the XP pipe with the metallic conduit. It does provide liquid type protective covering, and it enhances the resistance to crushing, kinking, and other types of physical damage. Importantly, it also provides added fire and UV protection, which a lot of the other pipe does not. Does not have UV protection at all. And it can be used in fresh water or saltwater marine applications. Specifically with the XPMD and some of the other marina pipes is they have installation instructions for marinas. You're not just using their general C-store truck stop installation instructions because these are not C-store truck stop type systems. Some additional pipe manufacturers that we found for marina use, Brugg has the Flexwell, Nupi also does have marina installation instructions, and it does have UV resistance. And then there's also the Omega Flex double track product that some people have used in Tennessee. There's going to be some other issues with the marina pipe you're going to find, or we found. There are some culprits out there. This will be Bonnie Beaver or Clyde Otter. We've had 3 facilities that have had fuel pipe damaged, and we've had one that we know of. I think the other one's probably had a release too, but a release that we know of for sure that occurred on Memorial Day. And they only had to operate with one product for Memorial Day. So it can be inconvenient some of the aquatic life. These animals are also been rumored, been told by some of the marina operators that they also like chewing on the rubber that you'll find on some outdrive transom seals, and they've also sank a few boats. So you got to be careful that the pipe you're putting out there in the water not only is going to get UV degradation or get kinked or broken by movement, but it can also be attacked by some aquatic mammals that are just curious and out to cause some mischief. The other thing that we looked at when we were looking at the NUI Glide ratings is we wanted some sort of line volume multiplier. Specifically, we wanted something for fuel lines. There was a lot out there for plumbing, sewer lines, just based on the internal diameter. But we did look around and we found the Veeder-Root Line Leak Application Guide. I think this is still published through them, and it has volumes in gallons per foot, if you look on the right hand, for all types of fuel pipes. This pretty much just shows rigid pipes and APT, but I just cut the top of it off so it would show up a little better. It actually encompasses pretty much all manufacturers and IDs, internal diameters of the pipe that they provide. So this is what we use in figuring out what line volumes are. Some of the leak detector third-party evaluations that we ran across. Red Jacket was very popular, as it is in all the C-stores and truck stops. They can use it there often because the length of piping is not all that great. But with marinas, as we showed, it can be very high. So the Red Jacket was pretty much good for 49 gallons on flexible pipe. Vaporless was good for 59.6. We have had some people move to Franklin Fueling's MLD Plus. It's their newer model. It does have a little higher volume evaluation, and it's also covered for mixed type pipelines, which is what you're going to have often at marinas. They'll go from a rigid pipe underground to a flexible pipe out on the dock and sometimes on the shoreline. Also with line tightness testing, Petrotype was very common in Tennessee. It was a little more limited with volume. We have had some marinas transition over to the Leighton O'Brien. It does have a little more volume allowed in its third-party evaluation, and it also is evaluated for combination piping as well. So I guess you might ask, what did we do with all our knowledge? So our committee visited each UST facility with the local compliance inspectors because we have marinas across our state. And we wanted to determine if there were any issues with material, equipment, or the release detection. After we did our evaluation, we met after each compliance inspection to discuss the findings on the materials, not just the general findings with release detection, CP, spill buckets, all that stuff, but the actual materials and issues that we're finding, with the Marina Committee. We issued return to compliance plans for each facility that had material, equipment, and release detection issues. Another thing that we did do is we worked with our enforcement discretion and provided an extended deadline so the owners and operators could budget for the repairs, because I'll go ahead and tell you that marina grade piping is not cheap. And also they have a very short season in which they operate. So that would allow them to work in the off season to get these repairs done. So what changed? We made sure that, any place that had down gradient piping had an anti-siphon device, because if we did have some issue with the piping, whether it be damage from movement or damage from marine mammals, we wanted to make sure that the contents of the tank were protected. We also made sure that the line leak detectors were not installed upstream of the anti-siphon solenoid. We wanted to make sure that they were installed downstream. When they were installed downstream, we made sure that a sump and sump sensor was installed to monitor the portion of pipe that was not protected by the leak detector. We made sure that the fuel transfer hose that we found everywhere in varying stages of decomposition, we made sure that it was taken out and replaced with pipe for marina use. And we also made sure that the leak detectors and line tightness testing methods were adequate for the pipeline volumes at the facilities. What was the result? We're still kind of going on with this process. We still have some that are within their return to compliance plan compliance deadlines. We have some that have already passed. And as you could expect, just being compliance inspectors mostly, facilities with good compliance history, they made the changes. There were some that did not, and they were sent to enforcement, where they're currently being given another opportunity to make the changes. As the committee, we also drafted some marina specific rules, including some of the things that we've discussed today, and hopefully we'll get those out in an upcoming rule package. So we don't have to, as I jokingly say, pound the square peg of marinas into the round hole of our UST regulations. And also, we did have some successes. There was one marina owner who took the opportunity when he was making some pipe changes to add some extra slips and dispensers to his fueling dock. And when I met with him after to go over what he'd done, he was actually very happy. His customers had provided great comments. It was easier for them to get in and out with the multiple fueling facilities, and the dock that he put in was much easier for them to get in and out of the boats. And his business has actually increased even more than just COVID related increases. So that's going to wrap it up. Thank you for your time. I appreciate you all being there. And if anybody has any questions, can open it up.
All righty. Excellent. Well, thank you so much, David. A lot of good photos and content there. So we did get quite a few questions. I don't know if it's easy for you as well, David, to open the chat, because some of these are pretty long questions. So I'll do my best to get through them, but you putting an eye on them might help as well. So I'll start off with some of the shorter ones here that came in.
Okay.
So the first is kind of a request. If you have a hyperlink for that California document you talked about earlier, if you want to throw that into the chat, great. Otherwise, we can coordinate offline, and I can either get the PDF or the link posted with the recording and slides after the fact. So if it's handy, please throw it in the chat. And if not, maybe either way, we can upload it on the website afterwards.
Yeah, I'm not sure I found it on their website earlier. This was years ago. I don't know if it's still there. I can supply you with the PDF though.
Perfect.
Download it.
Perfect. So whoever asked that question, yeah, we'll just make a plan to include that PDF with the information after the webinar on NUEPIC's archive. So thanks. One question is, I guess they're asking, can you discuss how cathodic protection works with metallic conduit?
Okay, most of the metallic conduit that we have is either underground or it's on a floating dock. We do still see some of that. If it's on a floating dock, we make sure that it's up out of the water. We have had some flexible connectors that we had found that have kind of worked their way down into the water. We made sure that those were pulled back up into the floating dock. But CP on that works pretty much just like CP does on any other piping at a retail fueling facility.
Okay, great. So a couple more. These are a little bit longer, so bear with me. All right, so this person sort of puts out a scenario and then asks a question. So the comment is, if the marina is in a tide zone or a floating dock and the pipe run install design portion above the water and not in soil is unregulated, if it ever becomes submerged for any amount of time, then is it regulated?
Well, Tim kind of commented on that earlier. What you're going to find is you're going to find that a lot of this piping that comes out from the shoreline transition area is going to be underground, or I'm sorry, underground. It's going to be underwater. Oftentimes, as it's coiled to allow for vertical movement during floods, you're going to find that it has embedded itself in the lake sediment. So a good argument, as Tim said, could be made that it is regulated by the UST rules. Now, when we first got into this, full disclosure, we asked our Attorney General for a legal opinion, and they gave us one. They said that our act, the Tennessee Act, would allow us to regulate it if we so chose to do so. They also said that the other edge of that sword was that if somebody made a claim against our fund for a release from this hose, whether it got eaten by an otter or broken in a storm, that we probably could not deny it. So that led us down the path of what was a good use of taxpayer funding sources, whether we should be covering, I guess, some of this above ground pipe that might be less than ideal with taxpayer dollars without requiring some changes. So we did require some changes.
Great, great.
Hey, Drew, this is
Yes.
Tim Smith. Hey, I wanted to circle back on this issue about underwater piping versus underground piping. There was a comment that I finally got into the comment section here, and this is very timely, where that piping that runs above the ground, it may go into the water, it may be embedded or in the soil, in the riverbed, so to speak. You really have to look at where the placement of that piping is. Underground, beneath the surface of the ground, that is fully regulated by the underground storage tank regulations, 40 CFR 280. That's transition to underwater. Underwater is not fully regulated by the underground storage tank regulations. Don't have to do release detection, that sort of thing. But if you look at the release response and the impact for owners and operators having to respond to, say, above ground releases at the US facility of those above ground components that could drip down and cause releases to at the US site, those are addressed and covered by the federal US regulations as far as cleanup response actions. They're not covered by the release detection, CP, and things like that. However, the underlying issue is that impact from releases from the underwater or above ground piping that could impact the federal US regulations or the US site, and it still could be covered under certain portions, cleanup, for instance, of the US regulations. So owners and operators, like I said, might not have to do the release detection for that underwater piping, but a release to the surface water from that underwater piping at the US site, US facility, could still pull them into being regulated from the other portions of the federal US regulations. Hopefully that is, those nuances are clear. I think I may have responded earlier and may have been misconstrued as underwater piping is regulated the same as underground piping, and it's not. Certain portions might be covered. Hopefully that clears up things.
Great. Yeah, thanks for clarifying, Tim. So there was one more longer question that came in from David's presentation. I'm going to hang on to this one if we do have time toward the end here. So please keep the questions coming, folks, if you would. I know we're hitting our third panelist now, so questions may relate to one or all of our speakers. If you would just clarify when you send them in who you're asking a question to, that's always helpful. And if it's a panel question, you could say for the panel, something like that. So again, thanks so much, David, for your presentation today.
All right, thank you, Drew.
All righty, and with that, it is my pleasure to hand it off to our third speaker. I'm happy to reintroduce Steve Latimer with Wilson Rogers and Associates. Excuse me. Take it away, Steve.
All right, thank you, Drew. I'm going to start by saying I think my two co-panelists here have done a great job of talking about the code requirements and aspects associated with marine fueling systems, and both the perspective of the governing body, the EPA, and the experience of a regulator inspecting these systems over the course of several years. I am going to kind of shift gears a little bit. And at this point, we're going to talk about new advancements in this industry and the piping and accessories that are commonly used in these applications. So again, Steve Latimer, Wilson Rogers. I'm up in the Pacific Northwest, Linwood, Washington. I am going to warn the group that we do have very high winds up here. I've got flickering lights, so I may lose power at any time. Hopefully that won't be the case and we can get through this presentation. So what I'm going to talk about is industry advancements and the advent of UL 1369, which is the UL listing for above ground piping for flammable and combustible liquids. I'm going to talk about underground piping in marina applications, above ground piping, the onshore piping transition sump, the dock transition sump, and the valves and accessories that are common to these types of applications. It's just unfathomable to me that as an industry, we made it until August of 2018 without a defined standard for the above ground piping used over our navigable waters and our lakes and rivers and streams. It's just incomprehensible that we made it that far with all the scrutiny and all the underground storage tank regulations and the standard retail fueling industry, and even the e-gen market, I think, was addressed before marina applications were really addressed. But with UL 1369, that's going to change. So prior to UL 1369, these are some examples of what was considered acceptable piping in a marina environment. You can see here we've got the fuel piping on the left coming down, single wall threaded fittings, transitioning to rubber dock hoses or excuse me, tank truck hose. Most often these hoses would be pressure tested and certified by US Coast Guard standards, but still uncontained joints and single wall out over the water. The one on the right, it's hard to discern in this picture which of these lines are fuel versus other utilities, but in any case, every one of these is uncontained. A couple of other examples here. The fuel piping, galvanized pipe comes right out of the buried ground, transitions here with a sweeping flex connector. Again, unions, threaded joints, all right there over the water. And then this is the other end of the picture shown previously. And if you can tell me which of those lines are fuel and which are other utilities, I would be very impressed. So thankfully, UL 1369 has been developed. It's no longer the case that we don't have a defined standard. UL 1369 was released in August of 2018. It's the standard for above ground piping for flammable and combustible liquids. It's applicable for above ground indoor and outdoor applications. That could be fueling, that could be generator, the whole host of indoor and outdoor fueling applications or fuel applications, as well as marina fuel handling applications. In October 2020, 2 manufacturers were awarded the UL 1369 designation. There are 2 manufacturers that are both very similar in their piping material. They're both a corrugated or I apologize, I'm drawing a blank on the other method, but flexible stainless steel piping and with a UV stable exterior jacket. You can see both of these fitting manufacturers here have interstitial test ports on their fitting so that you can test the interstitial space of the piping. To earn the UL designation, the manufacturers had to submit their piping and fittings for testing. And some of the testing criteria was pressure, physical testing, and that included drop, puncture, impact, torque, pull, crush, and bend. Severe corrosion resistance, including salt spray fog testing, Tide cycle testing, the requirement was for 10,000 cycles of flexing the pipe back and forth to simulate tidal movement. At least one of the manufacturers exceeded 100,000 cycles before terminating the test. Ultraviolet exposure, fire resistance with a minimum 30-minute at 100 or 1800 degree Fahrenheit test. The current listed manufacturers both achieved actually a 2-hour fire rated test. Fuel compatibility, they had to be compatible with all current known fuels of today and anticipated fuels of tomorrow, hence the 316 stainless steel pipe and fittings. And then anchorage and support methods to properly secure the piping to the fixed and floating docks. The scope of the UL 1369 covers the primary, secondary, and coaxial types of above ground pipes intended for the transfer and containment of flammable and combustible liquids. So gasoline, diesel, jet fuels, and the like. They can be flexible, it can be rigid, metallic, non-metallic, or composite. Composite materials are deemed to be like the flexible products that have been approved. The stainless steel primary with a thermoplastic exterior is considered a composite system. And it can be single continuous or multiple joined lengths from 1/2 inch to 6 inch diameter. That is the scope of UL 1369. Now, just because that is the scope and the type of materials allowed to be submitted, it doesn't necessarily mean that all of those materials will meet the criteria for testing to achieve the UL 1369 designation. Vehicle fueling systems, aviation fueling, boiler generator systems, and marina systems are the intended applications to utilize the UL 1369 piping. Products covered by the UL 1369 are intended to be installed in accordance with the applicable codes and regulations as determined by the AHJ, including, but not limited to, NFPA 30, 20, 30A, 31, 37, and the whole host of International Fire Code. There's also some implications with the International Mechanical Code, ASME Code. There's a whole host of documents that UL 1369 pertains to. And the 2021 edition of the NFPA 30 already includes UL 1369 verbiage in chapter 27.4.7.2. We also expect that the next edition of International Fire Code will also contain verbiage pertaining to UL 1369. Manufacturers of approved systems are allowed to have a dual pipe listing. UL 971 or 971A are the designations for underground piping, and UL 1369 for above ground piping for flammable and combustible liquids. That's actually very important, and it delayed the release or approval of the two manufacturers by about 9 to 10 months, because the verbiage in UL 971 actually stipulated that you could not have a UL 971 pipe that carried another UL designation. So there was about a 9 to 10 month delay in approval of the products because they had to go back and change the verbiage of UL 971 and 971A before they could issue that. So although the standard was created in August of 2018, the two manufacturers had completed their testing in 2019, but could not be awarded the UL 1369 designation until after that verbiage was changed in 971. But this allows for a single approved pipe system to be used all the way from the UST to the transition sump, through the bulkhead wall, down the gangway, and out to the dispenser. So one manufacturer, one complete system approach. Now, to be considered UL 1369 compliant, all sections of the double wall piping are required to be continuously monitored. So this touches on some of the things that Tim and David had presented. To be UL 1369, it is required to be continuously monitored. Now that can be accomplished with the sensors connected to your standard ATG system, whether it be Veeder-Root, Pneumacator, Omtech, Incon. All of those are quote unquote third-party NWGLDE certified leak detection devices, or it can be a standalone sensor system. Positive shutdown is not a requirement of UL 1369, but continuous monitoring is. So for underground piping, UL 971 can be rigid fiberglass, semi-rigid, which is fusion welded thermoplastic, or flexible. Considerations for the material selection should include distance, routing, flow rate, and as we touched on before, for the purpose of line leak detection, the pipeline volume. As each one of those types of piping have their own maximum volume that they can contain for compatible line leak detection devices. Now here I have just a few examples of fusion weld piping here, the semi-rigid. You can see the fusion weld couplings joining the lengths of piping together. Fiberglass, I'm sure everybody on this presentation is very familiar with fiberglass underground piping, or flexible piping, which can be continuous runs and must be void of any joints between the transition sumps. No direct buried joints with a flexible piping system. Now, pressurized systems, those using submersible turbine pumps to deliver the fuel, should be equipped with line leak detection, either mechanical or electronic, with positive shutdown. Now, this is, again, something that Tim and David have touched on, outlining what the EPA position is, and then David's experience with what he has seen in the marketplace. Only the underground portion of piping is required to be equipped with line leak detection. And the key there is, and this is one of the questions that has been brought up, the above ground portion of piping is not protected from thermal fluctuation. So if you have a system where you have a 3 gallon per hour line leak detection device installed, and the system pressurizes the underground portion of line and conducts its test, that underground portion of line is geothermally insulated. It's shielded from thermal fluctuation due to the cold air or direct sunlight. So you're getting a valid test on that underground portion. If you were to attempt to test all the way to the dispenser, you may have conditions where thermal changes, an extremely hot day with direct sunlight on the piping, causing that fuel to heat up and expand, that could actually mask a leak because it's heating up and expanding, which increases the pressure at a rate faster than what the leak detector is detecting an actual leak. So it's important that your line leak detection only tests the underground portion of the line. Now, you can certainly have a third party conduct a test of your above ground portion on an annual basis or as determined by your AHJ, but for the automatic line leak detection, we should only be testing the underground portion of the line. So as we discussed earlier on, many of the jurisdictions don't require listed piping systems at this time. Steel, threaded or welded, fiberglass, thermoplastic piping, rubber hose, combinations, those are frequently used. Prior to UL 1369 being an option, the above ground piping for a marina was very much a Frankenstein approach with very little regulation. As an example, you could have a section of piping that was UL 971 underground pipe, come up to the transition sump or poke through the bulkhead wall, where you would have an uncontained transition to a Coast Guard certified tidal loop or rubber tank truck style hose, another uncontained transition to a steel pipe running down the gangway, an uncontained transition to a tidal loop, again, that same flexible tank truck style hose, and then finally another uncontained transition back to your piping that ultimately runs down the dock. So this project, which was designed in 2017, used that approach. Thermoplastic piping was actually used in this environment, and the pipe, it's UL 971 listed, but it was not UV stable, was not impact rated, and frankly, was not intended or designed for this type of an application. They ran thermoplastic piping underneath the dock, suspended, transitioned to rubber hose, transitioned back to thermoplastic pipe down the gangway, back to rubber hose, and then again, thermoplastic pipe running down the dock or over to the dispenser. So in this case, there were 1, 2, 3, 4, at least 4 uncontained joints and transitions, as well as the fact that the piping material was not UV stable, fire resistant, or impact resistant. So from my experience, it's not a matter of if, but when this system is going to fail. There are many ways to install above ground marina fuel piping, but with the knowledge of UL 1369, there are few ways to do it correctly. UL 1369 allows for a system approach, eliminating almost all of the uncontained joints, if not all of them, while providing a robust tide cycle tested, fire rated, UV stable, and salt spray corrosion resistant installation that will withstand the test of time in the harshest of environments. Some manufacturers offer contained transitioning T's and 90s to allow for continuous flow of the interstitial space while branching out into multiple dispensers or making hard turns around corners on a dock environment. By utilizing common installation practices like an S-curve or sensidilic curve, you can actually run a continuous length of pipe from the onshore transition sump to the dock transition sump by coming out through the bulkhead wall and then sweeping back and forth along the gangway to allow for that movement and the tidal fluctuation. It's not always possible to install in this fashion, but in many cases, the system can be designed with enough slack in a flexible line to be able to accommodate those changes. So here's a depiction of the onshore transition sump. And this is a picture that came right out of PEI RP 1000, the Marina recommended practices for marina fueling. So here we'd have our double wall pipe coming in, our UL 971 pipe coming into the transition sump from the UST, isolation valve to be able to test, or excuse me, to isolate for testing purposes or maintenance and repair, solenoid valve with internal relief for your line leak detection testing, a safety breakaway valve that, similar to a breakaway on a retail dispenser, would pop at a given pressure and protect the line strain on the downstream, and then a leak detection sensor in that containment sump. And you can see here, even in the 2014 edition of RP 1000, they illustrate double wall pipe continuing out to the dock. The onshore sump provides containment for the transition from underground to above ground. It also houses those devices, the isolation valve, solenoid valve, for tank testing, or excuse me, for testing the underground piping and the safety breakaway. A sump leak detection sensor should also be installed to detect the presence of liquids. Now, you can use distinguishing, but it's not required to have a distinguishing leak sensor in that application. Now here's a typical example of the dock end of the transition sump. Again, double wall piping after you come down the gangway and arrive at the floating dock, a safety breakaway valve, an isolation valve, and again, a liquid detection sensor. Now, again, this is right out of RP 1000. They do illustrate a watertight cover on this sump. I've seen many installations where that is not the case, and water or liquid in that sump is very common. So it's important that all of these bulkhead penetrations are watertight and that that lid is watertight to prevent erroneous potential leak alarms. So much like the onshore transition sump, the dock transition sump provides containment for all of those valves and accessories, and a sump leak sensor should be used. Here's a good example of this is actually a dock transition sump. You can see here we have an isolation valve. There's a flanged connection here with a safety breakaway valve, and then the transition to the flexible pipe with watertight bulkhead penetrations. You can also notice here that the lid is gasketed and bolt down all the way around this sump. And a leak detection sensor is shown here. Now we're going to talk about some of the valves and accessories that are used in these systems. Solenoid valves, we've talked about extensively, can be used for both anti-siphon protection and line tightness testing application. For line tightness testing, the valve should be installed in the onshore transition sump just prior to penetrating the bulkhead wall and becoming exposed pipe. We want to test the underground portion, but again, we don't want to necessarily test the exposed portion of piping because of that thermal variant. For anti-siphon protection, the solenoid has got to be installed at the high point of the piping at an elevation higher than the top of the tank. And again, because of the tank position and outside of the flood zone, most of the time, marine fuel dispenser piping comes off the tank and descends down below that top of tank. So it's not uncommon to have two solenoid valves in an application, one being the anti-siphon that fires immediately when the turbine fires, and then one as the line tightness testing solenoid. Now, mechanical anti-siphon valves can also be used. They're designed to withstand a specified negative head pressure. Now, my experience is these valves are limited to a maximum 20 foot of differential. So if you have a marina application where that 20 feet is exceeded, then you would want to use a solenoid valve instead. Mechanical line leak detectors test the underground portion of the piping from the UST to the solenoid in the onshore transition sump. Leak detectors detect a leak rate greater than 3 gallons per hour at 10 PSI. That is considered a catastrophic leak detection rate. A time delay solenoid valve is required when using mechanical leak detectors. So that solenoid valve that is in the onshore transition sump would have to have a delay of anywhere from 5 to maybe 30 seconds, depending on your overall system, your resiliency of your line, bleed back potential, and that kind of thing in order to get an accurate test. If you don't delay that solenoid long enough, then you will get a false leak indication and slow flow condition. Electronic line leak detectors test the underground portion of the piping similar to mechanical line leak detectors, but they test at the conclusion of a fueling process rather than at the outset. So no delay is required on that solenoid valve when you're using electronic leak detection. ELLD systems are generally capable of detecting a 3 gallon per hour catastrophic, as well as performing the precision 0.1 or 0.2 line leak testing, the monthly or annual test that is often required on these systems. So again, mechanical line leak detector tests at the outset of the fueling operation, electronic tests at the conclusion, and typically in an electronic line leak detection system, that line is always going to maintain a little bit of positive pressure, where a mechanical leak application, the system will be allowed to relax at the end of the process and then pressurize at the onset or the beginning of a fuel process on the next application. Again, we talked about position of the solenoid valve relative to the mechanical leak detector. If you do have an anti-siphon valve, whether it be a solenoid or mechanical anti-siphon, the leak detector has to be downstream of that valve. If not, if it's upstream of the valve, then it will not be able to see downstream of that solenoid. So a leak detector T, which is just a T device with a special thread for accepting the leak detector, which inserts it to the specific appropriate depth, just like it would be in the outlet of a submersible turbine pump, has to be used. So if you have a solenoid valve for anti-siphon and also a solenoid valve for line leak detection downstream, then your leak detector T would be positioned downstream of the solenoid valve. The marine fuel breakaways installed in the onshore transition sump and the dock transition sump, they'll separate with 300 to 600 pounds of pull force, depends on the manufacturer. So if you have a hurricane or severe winds or significant fluctuation of your piping, whether it be tidal or what have you, then these devices could pull apart and double poppets would prevent the release of fuel. Some of them are single use and some of them can be repaired. It just depends on the manufacturer. Emergency shear valves or impact valves installed under the dispenser. I'm sure most of you are very familiar with these. Very similar or identical to the ones used in standard traditional vehicle fueling environments. And a fusible link at 165 degrees holds that valve open. So fire exposure would also cause this valve to slam shut and prevent continuing to feed a fire with fuel. Quick connect fittings can be used to facilitate tight spaces. Many dispenser containment sumps on dock applications are very shallow and there's not a lot of room to get in there and spin your fittings. So quick connect fittings can be used to mitigate that. But they can also be used in applications where you have to disconnect your piping and remove or reinstall lengths of piping due to extreme fluctuation, whether it's lake level. You may have a lake or a reservoir that's used for irrigation. So as the season goes on, that dock gets farther and farther away from the shore and you have to install sections of piping or applications like that. So quick disconnect fittings can be used in those applications. Isolation valves should be installed anywhere where line isolation would be required for testing, repair, or adding and removing sections. Threaded, flanged, or they also have ball valves in the same quick disconnect style or sanitary flange style for easy disassembly. Rolling hanger pipe supports can be used to help support the piping in on the gangway. And this is a very good method to keep the piping out of the water, but still have enough slack to facilitate the extreme tidal fluctuation. So here you can see in this example, there's a 20-foot expected king tide fluctuation. There is enough slack in that piping that as it lowers, the slack will be able to just roll easily in the roller clamp section, but is still supported in the fixed clamp section of the dock. So a rolling hanger can be used to take up that slack and keep that piping up out of the water. Marine fueling systems are going to experience minor fuel releases at the dispense point. That's pretty much a given. If any of you have ever fueled a boat before, you're going to have fuel drips and drops coming out of that nozzle that ultimately make it into the water. Marina fuel system operators have a responsibility to preserve and protect the environment from release to the extent possible. And the best way to limit that is to utilize a system approach to marina fuel conveyance piping and keep the fuel where it belongs. Use a contained system all the way from onshore to the boat or ship to shore, so to speak, and the appropriate leak detection and release detection equipment to ensure that we keep that fuel in the tank, in the piping, and in the boat and nowhere else. And with that, I'd be happy to field any questions.
All right, great. Thank you so much, Steve. And we did get a couple of questions in. Folks, we're doing pretty good on time today. So if you've been sitting on a question for Steve while he was presenting, feel free to send it in now. And then if there's other questions for the first two panelists, please send those in as well. And assuming we do have time, we'll work to circle back to those as well. So let me pull up what I have here for questions. So Steve, I'm not sure if you wanted to get too much into specific manufacturers. One of the questions, someone wants to know what manufacturer makes that safety brake. I don't know if you'd want to answer that or not.
Yeah, I chose to obviously to stay away from naming manufacturers in the presentation, but in fielding calls, I would be happy to. The particular image that I used in this presentation was an M. Carter breakaway. OPW also makes a high volume 2-inch and 1.5-inch breakaway as well. I don't know if theirs is UL listed or not, but they do make a high volume breakaway as well.
Great, thanks. Let's see here. So the next question it's two questions really. Are safety brakes only needed for floating docks? Should they also be used on fixed docks?
And the answer to that is RP 1000, PEI RP 1000, the recommended practice guide, recommends the use of breakaway devices. I don't believe I've ever seen a code document that requires the use of breakaway devices. So to that, I would say that on floating docks, if I am putting in a marina or if I am inspecting a marina, I am at the very least recommending that they be utilized on any marina where you have movement, you have tidal fluctuation, you have the potential that the piping could be pulled apart by nature, or could be if you have a situation where the piping is run under the dock and boats go under that dock and could clip that piping and create pull force. You know, those are all great places where you would want to put in those types of protection.
Great. All right, well, that's all I've seen come in since you started, Steve. I'm going to pause a moment and encourage the audience, if you're waiting to send in a question for Steve, please do so now. And I do have kind of a longer scenario type question that I'm happy to read off. In the meantime, I think this came for David, but I think we're at a point in the presentation now. I'll try to point the question to the speaker it was for, but I'm welcoming the panel to weigh in as well. So I'm going to scroll back up. This is one of the longer questions posed earlier. So this is for David. And it's about what you had discussed with automatic line leak detectors and submersible turbine pumps. So the question is, technically speaking, why is the ALLD at STP not a choice? Can the manufacturer look at update from 1988, since electronic solenoids may not have been common then? And what they've done then is the person asking the question lays out the configuration, the operation, and the testing. The configuration would be STP, ALLD, and solenoid. The operation would be with the STP on, immediate open of electronic solenoid, and ALLD checks the entire piping run. And then the testing, this is a long one. The testing is ALLD test equipment at dock dispensers, STP on, electronic solenoid immediately opens, ALLD checks piping run, opens, ALD opens, tester induces 3 gallon per hour leak, and the ALD shuts down. This person says it works, it's predictive of the entire piping run and water. So that was a lot. And David, that was the one I'd suggested you try to read earlier if you had the chance. Any feedback from you? And then I'll open it up to the rest of the panel to comment if you'd like to.
Well, our rule does require the release detection, the line leak detector in this instance, to be installed in accordance with the manufacturer's instructions. So the manufacturer does have instructions how it is to be installed. That's what we require. The technical aspects of why they want it downstream of the solenoid, I'm sure that the solenoid opening, when the STP is turned on, there might be that delay that does affect the line leak detector. If they want specifics on that, they probably need to contact the line leak detector manufacturer, because I'm sure they have much more information on that than I do. Steve might be able to chime in on it, since he seems to be versed in this as well.
Thank you. And so I touched on this just briefly. The way this scenario lays out, it tests all the way out to the dispenser. And again, it's potentially problematic and could mask a problem by doing that, because you're now, let's say hypothetically you have a 100-foot run of 1.5-inch pipe, and that volume is 20 gallons or so. And you conduct your test. If you're only testing that underground portion that's temperature stable, then you can get a reliable analysis by that mechanical line leak detector that that pipe is stable. So you delay that solenoid opening by 7 to 10 seconds, turbine comes on, solenoid's closed, it pressurizes, sees that stable pressure, and then valve opens. Now, if you move that valve all the way down to the dispenser and you've got, say, 300 feet of piping that's running on the dock and it's exposed and it's subject to thermal influence from warm air, the sun, warm water, what have you, that is different from that geothermally stable underground, now you have piping or fuel that's 55 degrees being pushed out into this piping that's, let's say, hypothetically 80 degrees. And as it comes in contact with that warmer pipe material, that energy transfers and the fuel expands. And it expands at a rate that is equal to the leak rate that's actually taking place anywhere along that pipe system, whether it be out on the dock or disguised underground. And so we're releasing fuel at a rate of 3 gallons per hour, which is not very much in terms of in the moment. And this fuel in the line now is expanding at a rate equal to or greater than that. Then our leak detector is not going to sense that leak, and it could go undetected for days, weeks, months, or even years. So it's important that we only test the underground portion with the approved ALLD devices. Now, a periodic test of that above ground piping, exposed piping, absolutely. But so that's my take on testing all the way to the dispenser. But in terms of position of the MLLD or ALLD to the solenoid valve or anti-siphon valve, the MLLD or ALLD has to be downstream of that solenoid valve in the sump, in the tank sump, because if it's not, then when that solenoid valve is closed, it's acting like an isolation of the rest of the piping downstream. So in terms of electronic line leak detection, if you run a process and then your electronic line leak detector is now trying to calculate leak rate in that line, but the solenoid valve 30 inches from that ALLD is closed, then that electronic line leak detector is only testing the portion of that line from the outlet of the turbine to that solenoid valve in the same sump. It is not able to see downstream. In a mechanical leak detector application, if you have that solenoid valve downstream of the MLLD, and let's say it activates immediately when the sump does, or when the turbine does, but you have a delay on the solenoid at the bulkhead wall or in the onshore transition sump, then on the surface, it looks like that would be okay because you're opening the flow path, you're testing that portion of line up to that solenoid valve. But at the end of that process, if you close that, that solenoid valve in the turbine sump at the same time the pump turns off, then you're trapping that positive pressure because the solenoid is going to close instantly. The turbine pump is going to wind down and it'll still have that pressure there. And that can cause the leak detector to never go back into its at-rest position. It'll stay in that full flow. So again, you can mask that potential leak condition. So that's why the MLLD or ALLD has to be installed downstream of that anti-siphon valve.
Great, thanks so much for the detailed response there. And there's a comment in the chat that I think you just kind of hit on there, Steve, so we won't spend more time on this one, but more in the chat, folks want to see that. So going back up to a question asked a moment ago, and I defer to you, Steve, on how you want to answer this one. The question is, was there a piping manufacturer that produced defective piping that all had to be replaced?
No, there's none that I know of specific to marine environments. I mean, I think most everybody on this event is familiar with the total containment piping and the challenges they experienced in the 90s and early 2000s. But there are none that I can say definitively that had a marine application that failed and had to be replaced. Again, marine fueling is something that has been the least regulated in my experience anyway, in my 26 years in this business. So, I mean, I've seen everything from garden hose on marinas to rubber hose to steel pipe to galvanized pipe to copper pipe. And in none of those instances was any of it ever deemed not meeting code.
Great, thanks. I'm going to go ahead and re-invite the audience to please keep sending questions in, and I'll see if I can go ahead and pull the screen share back. I'm going to open it again at this point, opening up questions for the entire panel, be they for Steve, David, or Tim, who started us off. So do have a little more time left on today's event, taking us up until 3 p.m. So great speakers here, great content. If you all have been sitting on a question, please send it on in. It looks like a couple are coming in now. And folks, the more specifically you frame it as a question for a specific speaker, the more helpful for me to try and read these off. So the question, is solenoid valve at bulkhead necessary if the piping run above ground to dispensers is relatively short, thereby eliminating some of those thermal change concerns? And that's probably for you, Steve. You were talking about thermal changes.
And my response would be to be compliant with EPA as Tim laid out. Yes, any piping above ground is going to be subject to thermal challenges and could potentially mask a condition. Even if it's a short run of piping, the rate of expansion, especially with diesel fuel, the rate of expansion is very significant. For every degree of increase, the rate is exponential, or the expansion rate is exponential, and, or excuse me, is substantial, and could easily mask an issue. Now, going back to what I believe David said, is it's really up to the manufacturer. For years in my career, one of the largest manufacturers of equipment in leak detection, being Veeder-Root Red Jacket, would essentially say, if there is any piping that comes above ground, then our product is not to be used in that environment. And that was both electronic and mechanical. I believe they have softened that stance a little bit, but it really comes down to manufacturers' written install instructions. And if a leak were to go undetected, what is the liability of the operator and installer that installed that that was in direct conflict with what the manufacturer's written installations instructions stated?
Great. Thank you. So there's kind of a comment here in the chat, and it's back to the line leak detector conversation. I'll read it aloud, and I invite the panel to respond to it if appropriate, or if you have more to say. So this person says, of note, NFPA 30A Chapter 11 references Chapter 5 for its piping installation requirements. Chapter 5 does not distinguish between above ground and underground piping in its requirements for leak detection on remote pressure pumping systems. They say essentially requiring that the line leak detector be functional for the entire length of piping. So just wanted to read that comment aloud for the recording. So still a little time left on our clock today, encouraging folks to send in any questions for Tim, David, or Steve before we wrap up.
All right, I'd like to just say to Bill, Bill, that's a great point. I'm not fluent in what exactly that chapter says. I'd be happy to research that and contact you regarding my opinion there, but I was not aware that lack of distinguishment existed. So I'd be happy to research that.
Great. So I'll read another here. This person sort of lays out a point of confusion and asks for further explanation. So the comment is, So in a state, I'm required to follow either UL 971 or UL 1369 for pipe, and UL 1369 says I must continuously monitor all the pipe run, but I can choose. I assume that's between those two things. As stated, EPA does not require testing of pipe over water above in water, right? Which standard would you use? Please explain. I'm not sure who the question's for. I know there's a lot there, but if anyone wants to comment on those UL standards, please feel free.
I'll take a shot at that, Drew. Russ, so UL 971 is the UL listing for underground piping. So the requirement by EPA and adopted by most states is that you have to have automatic line leak detection and or sump sensors, containment, release detection for UL 971. UL 1369 is the listing that takes precedence once that piping goes from a buried piping to an above ground exposed piping. So you can have both UL 971 and UL 1369 in the same system, but each one of those is going to be governed by different standards. Now, UL 1369, the UL listing states that in order for a pipe to meet UL 1369 or be installed in accordance with UL 1369, that pipe has to be continuously monitored, meaning secondary leak detection sensors. So sump leak sensors, or with the case of the fittings that I showed in my slide, the interstitial test port can be routed to a small reservoir where you can install a leak detection sensor. There's also the potential for vacuum monitored or pressure monitored interstitials. So that doesn't necessarily mean that you have to install leak detection in a UL 1369 pipe. If your governing code and standard, let's say the state of Alabama has their statutes for underground piping, but then they come out and say, okay, we're going to mandate the use of UL 1369 piping for above ground, then yes, in accordance with UL 1369, all of that above ground piping would have to be continuously monitored with leak detection sensors of some kind. But if the state comes out and says you can use UL 1369 piping, but it's not necessarily required, then no, you're not required to continuously monitor that section of above ground piping, but all of your underground piping still has to be monitored in accordance with EPA or local AHJ standards.
Great. Great,
This,
thanks.
hey,
Go ahead,
this is Tim. Real quick on the underground, underwater. Hopefully it is clear that the release detection requirements, corrosion protection, all of those performance requirements are for the underground, not the above water or above ground or above water or in water piping runs. So hopefully that's clear. And that 3 gallon per hour leak rate, that's applicable to the underground requirements. And I believe Steve, as he mentioned, you might be able to perform release detection, but maybe not at the 3 gallon per hour at 10 PSI for the above ground portion some other way. So you can still meet release detection requirements, but they may not be specific to the 3 gallon per hour, 10 PSI, specific to the federal regs for the underground line.
Great. Thanks for clarifying further there, Tim. So I see 2:50 Eastern on my time here, folks. I think we have probably 5 more minutes that we can take for Q&A here. Don't want to take the time if we don't need it, but it's a great opportunity to ask our panel anything on your mind that they've covered today. So I'll pause for a moment and keep things open in the chat. Keep an eye on that. If you have any questions you want to send in, please do. So I'm going to give it another 30 to 60 seconds. I'm seeing that the chat is slowing down a bit, but don't want to cut us off short. So I'll give it another minute before we bring us home.
Hey, Drew, while we are anticipating maybe a few other questions, I just wanted to circle back real quick on my slide 5. Let me see if I can pull it up real quick. I think it addresses some issues with the safe suction. I've got a lot of questions on it. I've wondered why. Look back at my slide 5, and I see that in my shorthand, I may have cut some corners here. Hopefully that's on screen. Can you guys see the slide?
Yes.
All right. When I use this shorthand safe, semicolon 3-year, I pulled all of the suction piping requirements onto one line to save some space here. Got a little quote unquote sloppy. Sorry about that. When I provide this final slides to Drew for posting, I will separate this. The safe suction is separate from this 3-year line tightness testing or 30-day monitoring requirement. This is for the American suction system that don't meet the 4 design configurations. So this should be on a separate line. I tried to separate it real quick, but didn't quite work. I think it caused more confusion than good. Sorry about that, folks.
Great. Yeah. Thanks so much for the clarification. And I did just get a question there, will this be archived? It certainly will. I'll go over that in a minute, but I did just put a link into the chat there for you to quickly access where our archive is. I know sometimes folks think it's a little bit buried in all the layers of our site. So that's for you there. So I'm going to give it another minute. Thanks for the clarification there. I'm seeing a lot of thank yous. We certainly thank all of you for being here and not seeing any questions coming in. So see if we can go ahead and wrap.